Hello everyone and welcome back. In this video, we are going to learn how to evaluate type 2 improper integrals. So an integral is said to be a type 2 improper integral if the function that you integrate has a discontinuity at a certain point, and if that discontinuous point is actually a part of the lower limit or the upper limit, or if it is in between lower limit and upper limit, then we call it a type 2 improper integral. Now for example, here 1 over x minus 1 has a vertical asymptote or has an infinite discontinuity when x is equal to 1, and 1 is actually in the lower limit. So this is a type 2 improper integral. Okay, now how do we evaluate this improper integral properly? Well, it's kind of similar to what we do in type 1 improper integrals. So the problem is at 1, so I'm going to replace 1 by t, okay, a letter, and then we take the limit, we let t goes to, now not to infinity, now we let t goes to 1, okay. All right, now what's going on here? Now there's one key piece of information missing here. Okay, we have to write this properly. Okay, now to understand what's missing, I'm going to explain it to you via a graph. Now think about this. Initially, we had to integrate this a function over the interval 1 to 5, right? We had to find the area under the curve in between 1 and 5. Now think about this. Now what we do is we replace, okay, we create a letter, we create a certain smaller interval starting from t to 5, okay, going from t to 5. Now where should we place this letter t? Should you place it somewhere in between this interval, or should you place it outside? Well, think about this. We have to place it in between 1 and 5. Then move that towards 1, right? Because you want to find the area over the interval 1 to 5. Now, if you place your t outside the interval 1 to 5, then when you move t towards 1, you're going to have this excess amount of area, extra amount of area. And you don't want that, right? So you have to place your t in between 1 and 5. Or you can think it in this way. Think about this. Let's draw the graph of 1 over x minus 1. So you have 1 here. There's a vertical asymptote at x is equal to 1, and that's the problem. And 1 over x minus 1, the function, the graph will look like this, right? So we had to find the area of this infinite region, right? Rather, what we do is we replace, we make a letter t, and we find the area until 5, right? So we make this finite, and then we are going to move t towards 1. That's what we are doing, right? Okay, so I hope that it makes sense. So that means the idea here is that you place t in between 1 and 5, and you move t towards 1 from the right hand side of 1. Try to understand this, okay? You have t in the right hand side of 1, and you move t towards 1 from the right hand side. So to imply that you're moving t towards 1 from the right hand side, you're gonna put a superscript over 1 as plus. So plus means you're moving towards 1 from the right hand side. So if you're moving towards 1 from the left hand side, you would put minus, okay? So that's the missing piece. So this is how you represent a type 2 improper integral properly, okay, with the limit idea, okay? So you have to always explicitly say from which direction you approach to the discontinuity, okay? All right, so let me rewrite this and find the integral. So we rewrote it as limit t goes to 1 from the right hand side, approach 1 from the right hand side, and this is what we want to solve now. So as usual, first we solve the integral. Okay, so if you integrate 1 over x minus 1, you're going to get natural log absolute x minus 1. And you have to evaluate it at 5 and t and subtract, right? Okay, so let's see. Limit when t goes to 1 from the right hand side. This is going to be ln 5 minus 1 is 4. 4 is a positive number, so you can drop the absolute value. There's no need of making it positive artificially. And let's substitute t. Now it's going to be t minus 1. T is positive because it's in between 1 and 5, so you can drop the absolute value there as well. Now let's make t get closer to 1. Well, when t goes to 1 from the right hand side, ln4 is a constant, so it's going to be ln4, limit of a constant is constant. Now when t approaches 1 from the right hand side, ln t minus 1. So let's quickly graph ln t minus 1. So there's going to be a vertical asymptote at 1 again. So ln t minus 1 will be something that look like this, right? Okay, I'm not the best artist, all right? All right, so it goes to negative infinity. So when t approaches to 1, okay, from the right hand side, ln t minus 1, this goes to negative infinity. Negative and negative, it's going to be altogether positive. So ln4 is a constant, constant plus infinity is plus infinity. So then this so this is infinite, okay, so the limit is infinite. So then we can say this integral is divergent. So the divergent and convergent criteria is same for type 1 and type 2, both type 1 and type 2 improper integrals, okay. Since the limit is infinite, this integral is divergent. Alright, now let's look at an example where again the function is, this function is again discontinuous when x is equal to 3. Now the discontinuous point, the point that has the discontinuity, now it's in the upper limit of the integral, okay. So how do we approach this now? Now the same idea, you want to integrate this function over the interval 0 to 3. So what you would do is, now you have the discontinuity at 3, so you would replace 3 by t, okay, and write the integral as usual and take the limit and let t goes to 3 now. Now again we have to say the direction. So you would put t in between 0 and 3 just like the previous case. But now you are approaching 3 from the left hand side. Now that's the difference, okay? So because of that you would put the direction, you would put it as minus because you are approaching from the left hand side, your superscript is going to be minus. Now that's how you would write the improper integral properly, okay. Now from here on you just need to evaluate the integral. So let's evaluate the integral. Now to evaluate this integral, I'm gonna write this integral, I'm gonna write x minus 3 square as x minus 3 to the negative power 2, okay. I'm gonna bring that term to the numerator. Okay, so now we can easily integrate from here on. Okay, so if you integrate x minus 3 square, it's going to be x minus 3 negative 2 plus 1 negative 1 divided by negative 1, and you want to evaluate it at t and 0 and subtract. So let's see what happens. Limit when t approaches to 3 from left hand side, it's going to be minus 1 over x minus 3, right? I brought this x minus 3 to the negative 1 into the denominator now. Now we want to evaluate at t and 0. Limit when t approaches to 3 from the left. Now if you evaluate, if you plug t, it's negative 1 over t minus 3 minus subtract minus 1 over, if you substitute 0, it's 0 minus 3, it's minus 3. Okay, right, now let's see what we get. So it's a limit when t goes to 3 from left, it's minus 1 over t minus 3 minus minus plus 1 over 3. Okay, let's see what we get. Now when t approaches to 3 from the left hand side, this part, okay, going to approach, so this term right here, it's going to approach to negative infinity. Now think about this. So t is approaching to 3 from the left hand side, so your t values are going to be less than 3. Approaching from left hand side means 2.8, 2.9, 2.99, 2.999. so these values going to be smaller, larger negative numbers. That means negative numbers closer to, extremely close to 0. So that means these values are going to negative infinity. This negative and this negative, it's going to be positive. positive infinity. So positive infinity plus limit of 1 over 3 is 1 over 3. So it's altogether infinity. So the limit is infinite. Again, this is a divergent improper integral. Okay, too bad we have two divergent examples. Okay, all right, but however, I want to summarize this before we moving into the next case. So what's the summary? Let's say you have an improper integral where you have to integrate f from a to b. Let's say your discontinuous point, you have the discontinuity at a. So then the way you write it is that the limit when t goes to, you approach to a from the right hand side. Okay, when the discontinuity is at the lower limit. Okay, so then you would replace this by a letter t and then do the integration. Now if you have the discontinuity at the upper limit, okay, so if the discontinuity occurs at the upper limit, the way you write this as limit t goes to b from the left hand side, you are integrating from a to t. So try to understand this and try to remember this. Okay, the side that you are approaching to this number implicating that is very important, otherwise it's wrong. You have to write it properly. That's very important. Okay, all right, so let's learn about the next case. That means the next case is the function is discontinuous for a value in between a and b. So if you have that case, how you would evaluate the integral, let's learn that in the next video. All right, okay, thank you very much. Bye bye.